Scientific Notation, Lesson 5 Notes. Starting with the review. Take a moment, pause your video, and complete the 2 review questions. When you're finished, unpause the video to check your work. Okay, for number 1. First step was power of product in the numerator, multiplication in the denominator. The next line of work, you had to divide, that's the cross-out stuff. Then you had to make the -3 exponent positive by taking the reciprocal or flipping it. And then last we did the power of a fraction. Please make sure you have all the work written down. Make sure you have everything correct. Pause your video to do so. Number 2 is done the exact same steps. You have power of product in the numerator, multiplication in the denominator. Then you have division. Next, you have to make the outside exponent positive by taking the reciprocal or flipping the fraction, and then power of a fraction. Again, make sure you have everything written down. Please do not miss any work. If you got anything wrong, please fix it. Pause your video to do so. All right, this lesson is on scientific notation. You've seen scientific notation before, you've worked with it before, but we might do something a little bit different this year than what you've done before. Plus, everybody needs a good reminder of how to do this. Anyway, so an ordinary penny contains about 26 trillion atoms. So that big, long number highlighted in purple is pronounced 26 trillion. The size of an atom is about 300 millionths of a centimeter across. 300 millionths is the the decimal number highlighted in green. So both of those numbers are really awkward numbers to work with. The way they're written right now, it's called standard notation. So the normal way that you write a number is called standard notation. So both those numbers, again, are in standard notation. And they're hard to work with, they're hard to even pronounce. Some of you might not even know how to say them by just looking at them. So what we do is we take these numbers and we put them in scientific notation. So an easier way of writing these numbers is in scientific notation. Pause your video, write that down. Scientific notation is a shorthand method of writing very large or very small numbers by using powers of 10. We're going to use exponents. So again, pause your video, get that definition written down. Okay, so 1.8 times 10 to the 4th is an example of what scientific notation looks like. Now there's 2 ways to write this. Oftentimes you will actually see it written with the x. So please write that down, or 1.8 times 10 to the 4th using the x. This is the one and only time in my class that we will use the x to show multiplication. Scientific notation is the only time you'll be permitted to use the x to show multiplication in this class. So I would accept either way. You could use the dot to show the multiplication, or you could use the x. So again, 1.8 times 10 to the 4th is an example of what scientific notation looks like. So in the penny example that we first talked about, the size of the penny written in scientific notation would be 2.0 times 10 to the 22nd. 2.0 times 10 to the 22nd. So the big long number that was 26 trillion is highlighted down here in purple. And the size of each atom is 3.0 times 10 to the -8 centimeters across. So here's what you need to recognize. If the number is, well, I should say the absolute value, because we will be working with negative numbers as well. If the absolute value of the number is greater than 1, you're going to have a positive exponent. So pause your video and get that written down. So again, if the absolute value of a number is greater than 1, it'll have a positive exponent. But if the absolute value of a number is less than 1, you're going to have a negative exponent. So again, If it's greater than 1, it'll have a positive exponent. Less than 1, it's going to have a negative exponent. If you have any questions on the definition of scientific notation or how to write it, please let me know.